Alright, so the last mathematical piece that we need to add in before we start really worrying about kinematics is the idea of vector subtraction. And fortunately, given the fact that we now know how to multiply vectors by scalars, we can make sense of what vector subtraction is trying to tell us. So when we want to look at a vector subtraction problem, so say here are two vectors A and B, and we're told that A, we're given its directions 25 degrees above the x-axis, B is 20 degrees away from the y-axis, A has a magnitude of 12 newtons, B has a magnitude of 8 newtons. And what I'm interested in is the vector A minus B. Okay? Graphically, there are two ways that I can deal with this. One is basically to just draw both my vectors from the origin and then draw from the tip of B to the tip of A. So basically you're sort of, again, going backwards through this. So you're going to start at B and go towards A. So that vector right there is the vector A minus B. The other way I can sort of think about this problem is to remember that, well, this is really, I can think of this as a vector addition problem, where what I'm doing is saying I want A plus the vector negative B, and then the vector negative B is basically the vector B times negative 1. So negative B is going to have the same magnitude and it's going to point in the opposite direction. So rather than pointing up and to the left, it's going to point down and to the right. So in this case, what I'm going to do is basically start by drawing my vector negative B and then just work a vector addition problem. So I'll move negative B so that it's tail to tip with vector A, and then I'll connect from first tail to last tip to get my vector A minus B. So in this case, what that would look like is first we would draw negative B, then we would work a vector addition problem by sliding negative B so that it's tail to tip with vector A, and then we would draw in the vector that connects from first tail to last tip, and this gives us our vector A minus B. So one subtle detail to sort of emphasize here is notice A minus B here started from the origin. A minus B in our first option started up here. But they're the same vector because vectors only care about magnitude and direction. They don't care about where they're located. So even though you might be inclined to think that this is a different vector because it starts in a different spot, it's not. This is still the same vector because they both have the same magnitude in the same direction. So that's how we deal with subtracting vectors graphically. Analytically, this is actually fairly straightforward because by this point you've gotten pretty comfortable breaking vectors up into components. So what we're going to do is we're going to take our two vectors and we're going to break them up into components. And so when I look at vector A, it's going to have a positive x component and a positive y component. It's got a magnitude of 12 newtons. I've got an angle here, 25-degree angle defined relative to the x-axis. So that tells me that the x component is going to be plus 12 cosine 25 and the y component is going to be plus 12 sine 25. Vector B, well, it's going to have a negative x component because it points back to the left, positive y because it points up. Again, vector B's got a magnitude of 8 newtons, and I've got a 20-degree angle here defined relative to the y-axis. So the x component of vector B will be negative 8 sine 20, and the y component will be positive 8 cosine 20. So what I'm basically going to do is just set up this equation that says A minus B equals C. And so we've seen that what that's going to mean is I'm going to have two equations, one for what's going on in x and one's for what's going on in y. And so all I'm going to do is just subtract the x component of A minus the x component of B. That's going to give me the x component of C. So this will be 12 cosine 25 minus negative 8 sine 20. So that's going to cancel and really give me a plus. And so this gives me a final component for vector C of 13.6 newtons. For y, same thing, I get to set up a second equation. And so my y equation is going to be the y component of vector A minus the y component of vector B is going to give me the y component of their subtraction. So 12 sine 25 minus 8 cosine 20 is going to give me minus 2.45 newtons. And you can see that our signs here make sense because we know from doing this graphically that our vector is longer than it is tall. And it's going to point to the right, positive x, and down, negative y. So a long way to the right, a little ways down. That's exactly the vector that we've got. So again, basically, if you can break up vectors into their components, then it's easy to go ahead and do vector subtraction in exactly the same way we would do vector addition.